Hello. So I want to briefly talk about how to use organocopper reagents in order to make alkanes. And this is just one way that we're going to see that we can make an alkane for alkane synthesis. Okay. So first off, you're going to use, this is technically using what's called lithium dialkylcuprates. And they are very good to use in the sense that they can be prepared from using the alkyl lithiums that we've seen already how to make earlier this chapter, along with the copper 1 halide, such as like copper 1 chloride, for example, or copper 1 bromide. Those are the two big ones. Typically, you're going to use either diethyl ether or THF. Once again, we're looking at these non-protic or these aprotic solvents that are polar, and you're going to get this intermediate R2CuLi and then the lithium salt. So the way that this reaction works is that the alkyl lithium group, it first reacts with the copper. And so, for example, we would have the electrons, because once again, the carbon is going to be more electronegative than the lithium. And so the electrons are going to go and attack, bang, once again, sound effects optional, bang into the copper, and then the halogen is going to be a leaving group. In this example here, we're using iodine. Then a second molecule, once again, will bang into the copper in order to get this cupric anion. Okay. Then what happens is that you can take this cupric anion in order to attack another alkyl halide. You're going to end up with a new alkane, this copper-containing alkyl group, and then the lithium salt. But this is one way that we can make a much larger alkane. Now, if you start off with something that's aromatic, and then you add in an alkyl halide, you can actually add the aromatic compound to the alkyl halide that you're looking at. So let's work an example of this. Okay. And I'm not going to work out the mechanism. We're just going to show like how this will be, used. So, for example, let's take two molecules. So it takes 2 moles of propylithium that we've already synthesized from before. We add that in with your copper, using something like DE or THF. And you're going to end up with the following. Okay. So we now have 2 propyl groups hanging off of this copper. Technically, it's an anion. Okay, so technically this is an anion, we'd have a lithium cation. Right, now what happens is this lithium dialkylcuprate anion can be used. So this can be used, and we're going to add in, let's say that we want to add in the following compound. So what happens here is the carbon of one of these groups will come, smack into the carbon that's adjacent to the halogen, kick off the halogen, and now we've created a new alkane. So I will write out the mechanism, which isn't so important. I should know this. Know the mechanism, that is. Okay, so let's draw first the propyl group that was being added, but now it's attached to the benzyl group. So I changed the color. This color indicates for the benzyl group. Let's do one more example here, and I'll try to keep the colors separate. Okay, this time let's say, for example, that we have, I'm just going to make it ethyl. Whoops. Technically, it's going to take 2 moles of ethyl lithium plus your copper, and I'm just going to leave it as a generic X. This time we'll say THF. Okay, it's going to go on to form the diethyl, in this instance, diethylcuprate anion. Right. Now, let's put in, and let's say let's add in, let's say a pentyl 1, 2, 3, 4, 5 Br. Okay. So now what's going to happen? The carbon's going to come down, smack the carbon that's adjacent or alpha to the bromide, and the bromide anion will be leaving. And so we're going to end up with the 2 carbons that were attached to the copper, and now the 5 carbons, 1, 2, 3, 4, 5, that was in the alkyl halide. And of course you'd want to be able to name this one. This would be heptane. Okay, now there is something that you need to keep in mind. The one caveat here is that you can only react these cuprate anions with either a methyl halide or a primary alkyl halide. Otherwise, you're going to do an elimination reaction and form like an alkene. Okay? So, once again, you have to realize that you've got to use either a methyl halide or a primary alkyl halide to react with the cuprate anion, or otherwise you will form an alkene. Must use either a methyl halide or a primary alkyl halide. Otherwise, you'll undergo elimination. Hopefully you got a kick out of hearing me talk as I type. Hopefully this helps.